is, again, the stuff I go over today with you guys, we have already learned. Okay, at some point during this year, whether it be first trimester or second trimester, or even now in third trimester, you guys have learned about linear functions, exponential functions, and quadratic functions. Nothing is new in terms of what I'm going to cover now, except how to compare them. Okay? So the nice thing about it is this stuff we already learned along the way. Okay? What I'm going to do is I'm going to break down each one of the functions, kind of see what we remember from each of them, and then we're going to be able to look at a graph and be able to tell what type of function we have. And then we're going to be able to look at a table and be able to look to identify what type of function we have, and then be able to write that function in whatever form we're talking about in terms of what function we're talking about. Okay, first of all, what is a linear function? What is the graph of a linear function going to be?
A straight line.
A straight line, a line, right? Okay, so we know this is going to be, a linear function is going to be a line, okay? So we understand that what's the equation we use, or the function we always use to graph a line? Y equals what? Mx plus b. Perfect, okay? So when we're talking about a linear function, we write our functions in the form of y equals mx plus b. Okay, slope-intercept form. This is our slope, and b is our what, guys? Our y-intercept, right, okay? Another thing I want to add to this, and I talked about this last hour, was we need to understand that whenever we're talking about a linear function, there's always a constant increase or a constant decrease. Okay, I want you to put that by this. Okay, I want you to put this over here. Okay, as maybe just a reminder. Well, let's just put it down here. You're always going to have a constant. Constant means it's the same. You're constantly adding or subtracting from your original value to get the next point on your graph. Okay, so it's a constant increase or a constant decrease. And that means we're going to be, this is whatever you're constantly increasing or decreasing by. Whoops, I'm sorry. Typo. It's supposed to be a decrease here. Okay, constant decrease. This, guys, is your slope. Okay, your m. So you're always going to be adding or subtracting the same value over and over and over again. Okay, so we understand that we're always adding or subtracting. Okay, so we're adding or subtracting. We understand that leads to linear function. Okay, all right. The other thing you need to know about what linear function is obviously what the graph looks like. And we already, Austin already told us that. The graph is going to be either a line that rises or falls from left to right. So it could be, this could be my line. Or the graph could look like this, couldn't it? It could be falling from left to right. Okay, so we understand that a linear function is going to be the graph of a what? Of a line. That it means that we're always going to be adding or subtracting. Okay, so there has to be a constant increase or a constant decrease. So that's the major points of emphasis for a linear function. Anyways, we did linear functions back in chapter 5. We did linear functions in chapter 6. So we understand how to graph linear functions. Okay? Alright, now we move on to exponential functions. An exponential function, guys, is obviously the graph of a curve. Remember when we had the curve going either rising or falling from left to right? Does anyone remember what the function, an exponential function was? Remember the form, what it was? Y equals a times b to the x. Good, remember that part, okay? There's our exponential function, okay? There was our linear function, okay? An exponential function, but what was our a? What did a represent? Anyone remember what a was? A was our y-intercept, right. This was our y-intercept in an exponential function, not an m. The a was our in this function was our y-intercept. Now, do we remember what b was? B was our growth or our decay factor. Good. It was our growth, it's been a while, or our decay factor, which means that depending on what B was, we knew whether it was a growth or decay. If, guys, remember, if B is greater than 1, what was it? It was a growth or decay?
Growth.
It was a growth, exactly. Okay? If B was between 0 and 1, it was a what?
Again?
It was a decay. Perfect. Okay. So we understand that when we looked at an exponential function, we could automatically determine whether it was a growth or decay by what our value of b was. Okay? Now, what did our graphs look like when we talked about an exponential function? If it was a growth, what did it do from left to right? Rise or fall? If it was a growth.
Rise.
It would rise, right. It would look like this. It would start very, very close to the x-axis and get larger and larger and get large very quickly. Remember what this point right here was? This was our y-intercept. So our y-intercept was 0, a. So it would be over 0 up so many points, or up so many values. That would be our y-intercept. Okay? Then, if it was a decay, it would do what from left to right if it was a decay?
Decrease.
It would decrease or would fall, right? So then we'd have a graph looking like this if it was a decay. This point being what? 0, a. So we understand that the y-intercept was always the point that was on the y-axis, okay, obviously, hence the expression y-intercept, okay? So does that come back? That was all from chapter 8, wasn't it? Exponential growth and decay, all right? Now, the last one, which we have just been working on in chapter 9 and chapter 10, is on quadratic functions. And this is obviously more familiar to you because it's more recent, okay? The equation would be y equals ax squared plus bx plus c. Right, but today's lesson we're going to focus on just the most basic types of quadratic function, which is in the form of y equals ax squared. So I want you to make sure that you just identify that. Okay, y equals ax squared. We understand a. What does a do for us? It determines what does it determine for us in terms of the parabola?
Opens up or down.
It opens up or down, exactly, Brandon. Good. Okay, so a is always going to determine whether our parabola opens up or down. If a is positive, it opens up. We have a min for a value. And if a is negative, it opens down, and we have a maximum value, okay, of our graph. So obviously, guys, if a is positive, we would have a graph looking somewhat like this, wouldn't we? Okay? We understand that every graph is a what? Of a quadratic. A parabola, right? If a is negative, then our parabola would look something like this, wouldn't it? Okay? So obviously, this is if a is less than 0, and if a is greater than 0, it's going to look like that. Okay? So we understand what everything is. Now, that's the basically. So what we're going to start off with in your homework tonight, and what we're going to start off with in terms of talking is, what if I just gave you a set of ordered pairs and said, plot these points and tell me what type of function it is? Could we do that? If you plotted a graph and it came up to be a curve, what would you say, what type of function would you tell me it was? Exponential, right. If you had a plot points and you came up with a parabola, what would you say, what type of function would you tell me it was? A quadratic. And then you plotted some other set of points and you came up with a line, would you tell me what type of function would it be?
Linear.
A linear. Does that make sense? So when we have to know what the graphs look like, it makes it pretty easy, doesn't it? Because all you need to know is that a linear is a line, a quadratic is a parabola, an exponential is a curve. Okay? All right, let me give you a second to make sure you have all that down, and we'll erase it and go into the harder part of this lesson, which is when we're given a table of values, can we come up with a function then? Okay?